Okay, I'm recording now. Perfect. Yeah, all right, guys. So what I'm gonna do, I'm gonna turn on my pencil. Let's see. All right. Yeah. So of course the test. It's so it's Wednesday next week. And as I said, I posted the review sheet. So the review sheet that's on Blackboard. Review sheet that's on Blackboard, and so what I'm gonna do today is we're gonna solve problems 6 and 6 and 7. So 6, this is about section 8.1, and then 7, it's about section 8.2 in the in the review sheet. And then so if you have time, we're gonna finish, and then so this is our plan today. Okay, so and then so solve the problems in the review sheet, problems 6 and 7, and then finish section 8.3. Okay. So as I said, so the review sheet is on Blackboard, guys. So it would be a good idea if you try to solve the problems in the review sheet, and then next week when we're gonna have a review, if you have you can prepare your questions. If you have any question about the review sheet or the homeworks, or so then I can probably answer your questions. So I can probably answer your questions next week in the during the review. All right, so yeah, so let's do the problems. So there's the review sheet. Let's do first problem 6 and the review sheet. So this is, so again, the review sheet is on Blackboard, guys. So this is section 8.1. And in the homework, guys, the homework number 7, right? The first exercise. So exercise, just to remind you that exercise 1 in the homework, exercise 1 in homework 7 is, so it's about this section 8.1, right? So it's, so this problem number 6, it's very similar to the problem you have on the exercise 1 in the homework 7. All right, so what does it say in this problem number 6? So it says the following: a random sample. I'm gonna write down the problem. So random sample of 40 farming regions gave a sample mean price X bar. So it's actually $7. So that's $7.50 per 100 pounds of watermelon. So you assume sigma, the population standard deviation sigma, to be equal to 1.8 or $1.08. Then you need to find 95% confidence interval for the mean price mu. So for the mean price mu. So again, guys, so as you can see here, so this chapter 8, it's all about this confidence interval. Okay, so chapter 8, it's just about this confidence interval. So whenever you see the word confidence interval in a problem, so that will be one of the sections in chapter 8. Okay, so confidence interval. So the key word here, of course, that it would be confidence interval. So confidence interval. So then that will be either section 8.1 or section 8.2, and then actually it's also about that's also in the section 8.3. Anyway, so if you check the exercise, the homework, your homework number 7, the first exercise. Let me just find the homework number 7. See right here. Okay. So as you can see, so we have a random sample of 45 male firefighters, etc. And we have there's a sample mean X bar. You have your standard population standard deviation sigma, etc. But then it says find the 99% confidence interval for the population mean, etc. So yeah, so this is very similar to the exercise 1 in the homework 7. Okay, so so what's a confidence interval? So I'm gonna just remind you, confidence interval is given by, so it's X bar minus E, X bar plus E. So the X bar, that's the sample mean. So X bar is the sample mean. And so as you can see, the X bar, it's given, right? So the X bar, it's right here, the sample mean price, X bar. So it's $7.15. So the X bar, it's given. Right. Now the E, the margin, so that's the margin of error, E. Okay. Now, so the problem is, how do we compute this E? Right, the X bar, it's always given in the problem. So the problem is, how do we compute E, right? So then there are two cases. So to compute this E, so the question is, how do we compute E? Okay, so then there are two cases. So first case, this is when sigma is known or given. Okay, and the second case, this is when sigma is unknown. Sigma, that's the population standard deviation, right? No, what I mean by known, of course, or what I mean by known is it's given in the problem. So like here in this problem, and like in the exercise 1 in the homework 7, it says, well, assume sigma to be equal to $1.80, right? So sigma, like in this problem, sigma is given. It's in the problem, right? It's given. So we are in the case when sigma is known. Okay, so sigma is known in this problem. So sigma is known. So that will be, so that's actually section 8.1. Sigma unknown, that will be section 8.2. All right, now, so when sigma is known, then the formula for E, the margin of error E would be Z subscript C times sigma over square root of n. Okay, that will be your E. That's how we compute the E. So let me just explain here. The sigma, of course, that's the standard deviation, the population standard deviation. The n, that's the size of the sample. You have a, like here, it says a random sample of 40 farming regions, right? So we have a sample of size 40, right? So the n, let me just write it down here. So n, that's the size of the sample. Sigma, that's the population standard deviation. Now this Z subscript C. So how do we find this Z subscript C? So this is called the critical value. The C, that's your, the C here, that's the confidence level. right? C, that's your confidence level. And to find this Z subscript C, you need to use the table. There's a small table in the bottom of the table fee. So this is table fee, okay? So let me show you here the formula sheet, right? So this Z subscript C, you need to go to the table fee, and there is in the second next page. You see here in the bottom, on the left,
Yeah.
you see there's a level of confidence C, critical value Z subscript C. So you can get your Z subscript C from this table. All right, that's where you get your Z subscript C. So for example, here in this problem, it says, what's C? The confidence level, that's the percentage you have just before your confidence interval. So here it says 95, it says 95 confidence interval, 95% confidence interval. So your confidence level is this 95%. That's your C, right? So here, our C is 95%. So C is 95%. So then this Z subscript C would be, we can go to our table, and 95%, 1, 2, 3, 4, 5, 6,
1.96.
1.96. Thank you. So that's just 1.96. 1.96. Oops. And then you're done, because once you have your Z subscript C, now we can compute the margin of error E, right? So then E, as we said, it's Z subscript C sigma over square root of n. So it's 1.96 multiplied by sigma, which is in this problem, it's given. It says 1.8, right? It's 1.8. So this is 1.8 divided by square root of n, and that's the size of the sample. So that's like so like here we have, it says random sample of 40 farming regions. So the size of the sample is 40, 40. Right? So square root. So this is over. Oops. Okay. I don't know why this app freezes sometimes. It's annoying. Okay, so square root of 40. All right, so then, all right, so let's complete this thing. Actually, I don't really have the details of the computation, so I need to do it now. So it's 1.96 times 1.8.
3.52.
Thank you, 3.52.
It's 3.52, and then it has
8.
So
yeah, let's. So let's keep the 8, and over square root of 40. So the answer.
And the square root is 6.324.
Yeah, 6.324. Thank you. And the answer, it's 0.557. Let's just write 5.5. And again, it's up to you guys. You can round up your answer. That's not a problem.
Is it okay if it's 0.56?
Yeah, it's okay.
Thank you.
Yeah, because the answers in both answers are going to be very close. So yeah, sure. And so once you have your E, guys, then you can answer. You are done, because then your confidence interval. So it's X bar minus E, X bar plus E, X bar. We said it's given. It's right here. It's 7.15. 7.15 minus E, 0.55. 7.15 plus 0.55, and yeah, so that's I think it's a 6.6, and this is 7.7.
Yeah, 71.
Or 70. Doesn't matter. The 0 doesn't change the answer. So yeah, and then yeah, that's the final answer, right? And again, the interpretation is the following, guys. So we are sure, actually in this case, we are 95% sure that the population mean mu belongs to this interval. It's between these two numbers. So this is the case when your sigma is known, right? Sigma is given. All right. Now, if we move to the next problem, let me see, where is it? Yeah. So this is, any questions so far? So this is when sigma is known. So whenever you see the confidence interval, first thing to do is try to see if sigma is known or unknown, if sigma is given or not. Okay. So like the next problem 7 in the review sheet. Again, we are solving problem 7 review sheet. So this problem is very similar to the exercise 2 in the homework 7. To exercise 2, right? Just see, make sure that this is no, sorry. Actually, there are 3 exercises in the homework 7. The first 2 exercises, that are very similar to the problem we had, but then the exercise 3. So this is similar to the exercise 3 in homework 7. So the previous problem 6, this is the same as the exercise 1 and 2. Not just 1, but 1 and 2. So I mean, in the homework number 7, if you check exercises 1 and 2, you can see that sigma is known, right? In both cases, in both exercises, the sigma is given. Like exercise 1, sigma is 7.5. Exercise 2, sigma is like 18,250. Okay, so all right. So what do we do in this case when sigma is unknown? Well, when sigma is unknown, then we have a different formula for the margin of error E. So then this margin of error E would be equal to, so E would be equal to, so it's a different variable. It's not a variable Z, it's going to be a variable T, subscript C. And instead of sigma, because sigma is unknown in this case, so it's going to be the sample standard deviation S over square root of F. Okay. So S, that's the sample standard deviation. Okay. And this T subscript C, this is, you can find this T subscript C in table number 4 in the formula sheet. All right, so now so let's solve this problem number 7 in the review sheet. So it says the number of goals scored by 10 different NHL hockey players in the last season are, so we have like 10, I think 10 different values. So let me just write down here the problem. So it says the number of goals scored by 10 different NHL hockey players in the last season are, so we have 10, 13, 21, 15, 23, 40, sorry, 20. Okay. 10, 13, 21, 15, 23, 20, and then 14, and then 25, and then 10, and then 35. All right, so this is very similar to the exercise 3 in the homework, right? In the homework, we have like the values are kind of small. You have like 10 different values. You have like 4, 6, 7, 3, 5, etc. Right in the homework. But anyway, so and then it says so you need to compute the mean in A. So A. So this is again very similar to the exercise 3 in the homework. So it says compute the mean, the sample mean first, sample mean X bar, right? So how do we compute X bar? The sample mean is just you take the sum of all the data values. You know, you take 10 plus 13, 21 plus 15, 23, it's 20 plus 14 plus 25 plus 10 plus 35 over the whole thing over 10. Because over 10, it's because we have, you know, 10 values, 10 different values. That's the size of our sample. We have 10 different values. All right. Yeah. So then, all right. So I need to
186.
186 in the top. Thank you so much. Appreciate it. Over 10, which is 18.6.
Yeah.
Did you solve already the problem, Yanine?
I'm on the third step right now. Yes.
Oh, okay. Okay. Cool. Thank you. Thank you. So yeah. So that's your sample mean. All right. Now, so next, so compute the sample mean, and then we need to compute the sample standard deviation S. So we need to compute the sample standard deviation S. All right, so this is the S you need for the margin of error E, right? Remember we said in this margin of error E, there is S. So that's the S you're gonna use in the formula of E. Okay, the formula of E, you have the S, right? So you need to compute the S. All right, so well, let's do this. So as a first step, we're gonna compute the variance. So step one. So we're gonna compute the S square first. That's the variance. So at step one, I'm gonna compute the variance, which is S square. So I'm gonna just remind you the formula. I'm gonna remind you the formula of S square. Okay, so it's a sum. So we're gonna have a sum of X. X, that's the value, your data value, right? We have 10 different data values, right? You have 10, 13, 21, 15, 23, etc. So X represent your data value minus X bar, the sample mean. And then take difference and then apply the square. And then you divide the whole thing by n minus 1, right? So in our case, that will be, so first axis, for example, first axis is 10, right? So it's like, so 10 minus 18.6 square. The square, you apply the square to the difference. So first you need to compute the difference and then apply the square, okay? Difference first and then apply the square. So this is for 10. Do the same thing plus, so it's a summation because we have a sum. It's a plus, next value of X, it's 13, right? Next data value, it's 13. So 13 minus 18.6 square plus 21 minus next value 21, 18.6 square. Well, I don't have, I guess, enough space here. I mean, of course I can continue. So 21, next we have 15.
Can I ask you a question, Professor?
Yeah, please.
When I did mine, I have the squared. I have X minus X bar squared, but I have X minus X X bar. So I have, like, for instance, like 4 minus 5.8, and then that equals like negative 1.8. And then
That's
next
right.
to it, I have X minus X bar squared, and then I have negative 1.82 equals 3.24. So I'm supposed to do the squaring first because I did the subtraction first and then the squaring because I made like a chart.
Yeah. So first the subtraction and then the square.
Oh, okay. So I did do it right.
Yeah, you did it right. Yeah.
Okay.
Yeah. So for example, here, I'm gonna just write here plus etc. Right? So you have to do the same thing for all the data values, right? And then we are supposed to divide by, don't forget to divide at the end, to divide by n minus 1. We have 10 numbers, so that's 10 minus 1. So yes, so for example, first I do the 10 minus 18.6. So 10 minus 18.6, that's negative 8.6, right? So I subtract it first, and then, like, I have my parentheses, there is a square outside the parentheses, right? So this is like PEMDAS rule. PEMDAS rule, parentheses first. So you do what's inside the parentheses first, and then you have the exponent, right? So parentheses first, and then exponent. Plus negative again, 5.6 square plus this is 2.4 square plus next value, it's 15. So it's negative 3.6 square plus next value after 15, we have 23. So that's positive 4.4 square plus 20. So that's 1.4 square plus, let me just here,
Negative 4.6.
Next value, it's, oh yeah, 14, yeah, negative 4.6. Thank you, Yanni. Thank you, appreciate
And then is 6.4.
6.4. Thank you, appreciate it.
Then
6.
Negative 8.6.
Negative 8.6, that's right.
And last one, 16.4.
16.4. Thank you. And so this whole thing here, of course, divided by, yeah, so this whole thing here divided by 9. So, all right, so now, all right, so let's compare this to squares. So like you take the first square, right? So now I'm gonna apply the squares. The square of negative, it's always positive, okay? So after, when you apply the square, everything is gonna be positive, all right? Because the square of a negative number is positive. So like for negative 8.6 squared, that will be positive 73.96, okay? And then you have 5.6 squared. So that would be equal to 31.36. And then you have 2.4 square, which is actually equal to square. So it's 5.76 plus 3.6 square. That's 12, sorry, 12.96. Okay, so this is for 3.6. Then for 4.4, 4.4 square. So that's 19.36. And then you have 1.4 square. So that will be 1.96. And then you have negative 4.6 square. And as I said, when you apply the square, you're gonna have a positive answer. So that's 21 plus 21.16 plus what else? Yes. So we have 6.4 square, which is actually you see here. So it's 40.96 plus negative 8.6 square. Negative doesn't matter because the answer is going to be positive anyway. So square, that will be 73.
73.96.
Absolutely. And then the
200,
yes.
96.
Yes. Thank you. 268. So 0.96. So, and again, the whole thing divided by the whole sum divided by 9. All right, so let's do the sum in the top. So this is, let's see, I don't have the answer. Sorry about that, guys. So I need to complete
It's
this.
550.4.
550.
Yeah, divided by, yeah, 0.4.
0.4. Okay, thank you.
Yeah.
Divide by 9.
And then divided by 9 is 61.155.
Thank you so much. I appreciate it. Yes. So that's your variance. So that's your S square. All right. Now, this step 2 would be to take the square root of this. Kayla, does this make sense to you now? You see how it works?
It does, because yeah, that
Okay.
makes sense. And I'm at the bottom. I had gotten confused at the bottom part, and my laptop just died, so I had to log in on my phone.
Okay, no problem. Okay.
But so that's like part 2 on exercise 3 though, right? Because we still didn't find the confidence.
Yes. So this is the first part. So no, this is the first part. This is the first part of exercise 3. Right, the first part says compute the sample mean and the sample standard deviation. So this is the first part.
But I wonder, did I do something wrong? Because I did subtraction and squaring.
Yeah. That's what I did here. Like 10 minus, like.
Oh, you did. I see it.
Yeah. I like 10, like 10 minus 8, 18.6. I subtracted, so that's negative 8.6, and then I compute the square of the negative 8.6.
Okay.
And that will be that's the 73.96. Okay. Okay. All right. So then, so then step 2, just take the square root of that square. So that's square root of 61.155. Let me just see here. Square root of
7.82.
7.82. Thank you so much, Annie. So that's your sample standard deviation S. All right, now we can answer the second part of the question. Well, in this problem, it says, so that's the first part. Second part of the problem, it says, and again, this is very similar to the problem in the homework, exercise 3 in the homework. So the second part, so we need to find, it says find 90% confidence interval for the population mean mu, population mean.
Recording in progress.
Is there a problem with my Zoom? Okay, let me check. Sorry about that. Oh, Nival, you are here. Thank you. Gotcha. Thank you. Let me just see if. All right. Okay, there's no problem. It works. All right. All right. I'm gonna take a couple of seconds, I guess. So yeah, you need to find 90% confidence interval for the population mean mu, which is actually the number of goals scored by NHL hockey players in the last season. So, so we need to find 90% confidence interval for mu. All right. So, so as usual, so confidence interval, that's X bar minus E, X bar plus E. That's what we mean by the confidence interval. X bar, we computed X bar in the first part, right? X bar, this is actually, we said 18.6, the average number of average number of goals scored by the 10 hockey players. So it's 18.6. Okay, so this was computed in part 1, first part of the problem. All right, so we have our X bar. Now, what about the E? Well, as I said, so here, as you can see, the sigma, it's not given. Sigma is unknown. It's not given. We don't know what sigma here, right? So if sigma is as a known, then the E would be T subscript C S over square root of N. All right. Now, how do we find this T subscript C? Well, as we said, we need to use the table 4. Our C confidence level is 90% because we need to find a 90% confidence interval. So C is 90%. But then you need to use this table 4, you need N minus 1. And N minus 1, it's called this degree of freedom. So DF, that's the degree of freedom, which is N minus 1. N, that's the number of data values. We have 10 numbers here, right? So N minus 1 is just, so N minus 1 is 10 minus 1, that will be a 9, right? So again, the 10, that's because we have 10 numbers. So 10 minus 1, that will be 9. So my confidence level is 90% and my degree of freedom is 9. So let's go to the...
No, we will have to go down to 9, not 10.
Yes, we need to go down to, yeah,
To number
to
9.
not 10. So, yeah, to number 9. So, so if we go to the table 4 right here, right? So we go down first column, right? You go down to 9, not 10. That's the thing, 9, and then confidence level, it's 90%. The confidence level, it's the, so forget about the first 2 rows in the top, guys. The first row, it says like one tail area. You can forget about it. The second row, the same. So the third row, you have your C. That's where you have your C in the third row in the top. So like it starts with the 0.500, then 0.750, 0.800, etc. You have we have 90%. So 90%, that's 0.90. And so the answer would be 1.833. Okay, 1.833.
But for the formula, on number,
Yes. Yeah.
the letter N, we leave it under the square root. N would be still 10, correct?
Yeah.
Okay.
Yeah.
I was.
Yeah. Yeah.
So Professor, so my answer that I got when I computed the sample mean and the standard deviation, that answer that I got, right? That 1.93, I go on table 4 and I find that. And because I'm doing 10 minus 1, so my N is 9. So
Yeah. So 9. And what's your confidence level? In the exercise.
it's 98, and I have to go to the chart, and I have to go to chart 4, but I'm trying to figure out how to read chart 4 right now.
Yeah. So yeah, let me show you. You see in the, let me show you here in the chart. Table 4. So you see the third row, it says 0.500, 0.750, 0.800, and then you need 98%. So that'll be 0.980. You see the 0.980 in the top, in the third row?
Yeah, 0.850 and then 0.900.
And then
I see, look, I'm looking at it. I see the one tail area, and then it says
forget, no, that's the thing. Forget about the one tail area and the two tail area. No, the third row, that's 0.500.
Oh yeah, no, I see it. I see it.
Okay, you see the 0.98?
0. Yes, I do.
So that's where you have to go. That's your confidence level. And with 9 degree of freedom, so you need to go down to 9. You go down to 9. So like that, so then you need, I guess, 2.821.
Yeah, 2.821.
You see it? Yeah.
Yes.
That's, I guess, what you need for the exercise. Yeah. But in our case, we said it's what did we say in the problem, the review sheet, 90%. So, and confidence level 9. So we said it's 1.833. So this is this T subscript C. What happened? Okay. Okay. I don't know what happened, but okay. I think I need to change the app. All
So
right.
when we have like how it says
Uh,
0.500, 0.75, is that 50? Like, is that gonna be
Uh-huh.
like 50%, 75%, 80, 85%,
yeah,
90,
yeah,
95? Okay,
Yes.
Yeah,
Yeah,
just
absolutely,
ignore the
yeah.
last zero.
all right.
Yeah. Yeah. Just to forget about the last.
And
zero.
that's it, Professor? That's it?
Well, we are not done yet. So,
Okay.
sorry, just 1 second. I need to solve this problem. I
It's all
don't
right.
know what's going on with.
Mute myself.
What's going on here? All right, go to settings. Okay, it has to happen now. Okay. Okay, you know what? I can just use probably the Zoom board. Okay, I'm gonna just stop sharing. Okay. Sorry about that, guys. Where's the Zoom board? I don't know. Okay. Okay. I don't see the. All right. Where's the board? Okay. Okay, I don't see the option here where you can find the board in the Zoom. Okay, so I guess I have to go to the. Okay, I need to use my. Sorry about that again. So I guess I need to use this board, and probably I need to clear some space. How to do that? Okay. Okay. Select all. And then, okay, I'm gonna just delete. Of course. Oh, okay. It works now. All right. So let's open again the app. All right, now it's working. Do you see the board, guys?
Yes.
Yes.
Okay.
I see
Thank
it.
you. I'm so sorry about that, guys. I think there was no enough space in the, I don't know, for some reason in the app. All right, so yeah, I was saying that the E would be the T subscript C times the S square root of N. So T subscript C in our case, because we said, so this degree of freedom, it's 9. It's 9. It's 9, and we said our confidence level is 90%, so that's 0.90. So the T subscript C would be table 4. So 9, 90%, that's 1.8833. So 1. So this is 1.833 times S. So we compute this the standard deviation, and which was, of course, I lost the standard deviation. What was the S? Our S?
7.82.
Say it again. Sorry.
7.82.
Thank you. Thank you. Appreciate it. Over square root of n, and that's the size of the sample. We have 10 data values, so that's the square root of 10. Yeah,
When
so
you
then
go to the top, it's 14,
Yeah.
14.33.
0.33. Thank you. And
14, you put 40.
Oh,
I'm sorry.
14. Sorry.
Yeah.
Sorry, 14. Thank you. Yeah, it makes more sense. Yeah. And square root of 10, that's actually equal to 3.16. And so the answer, so
4.53.
Thank you.
Is-
Yeah. So it's 4.53. Thank you. So that's your E. So once we have your E, now we can answer the question. So the X bar minus E, X bar plus E. So X bar, we computed the X bar in the first part, and I think it's 18.6. If not, thank you. 18.6 minus the E, 4.53, and 18.6 plus the 4.53. So that's 23 point. So the answer. So that's sorry, minus. This is minus. So that's 14.07. And this is 23.13.
13.
Thank you. So that's your confidence interval.
Professor, I have a question.
Yeah, please.
Is there a possibility that the answer is between a negative and a positive number?
I'm
I'm not talking about now. I'm talking about like in
general. In
Yes.
general. Well, it depends. It depends on what's your variable, because like in this problem, the variable is what's the variable here? It's the number of goals scored, right? So number of goals, it cannot be negative. It's always positive. But if you have like something that can be negative, for example, temperature, right? So we have like temperatures, we have data values. So some temperatures they can be negative, right? So then your average, it can be negative. So yes. So yes, you can have negative values here. It depends on your variable.
The reason I asked is because I noticed on the homework, the last one, you see how you have X bar minus E. I have minus X bar, and that's how I lined it up. And then I'm like, why is this answer negative? But I see what I did wrong. I cannot switch them from places.
No, you cannot.
Like the X bar and E, it has to be X bar first,
Yes.
and then the E.
Yeah, absolutely. It has to be X bar first.
Yeah, I'm like, what? I have the computations right. It's just that one part on the bottom. I flipped it around.
Yeah,
so I'm glad I asked the question.
Yeah, that's a good point. Actually, that's a good point. But as I said, in general, this interval, you can end up with negative values when your variable can be negative. So it depends on the variable. It depends on
what page. I'm gonna resend you the last page.
Sure, no problem. No problem.
Okay.
Any other question? Kayla, you think you're good? You can. Solve.
I got a little confused. I was trying to keep
Where?
up. So, all right, I know I go to chart 4. I have 2.821, and then I need to have my standard deviation. You said.
Yes. So we have your standard deviation from the first part.
From the second question, right?
Yeah. I mean,
and that was
no. But I mean, in the exercise, in the exercise 3. So there's the first part where you compute the sample mean X bar and the sample standard deviation S.
Yeah.
So that's where you get the S.
Okay. Yeah, that's what I was looking at. So I have my S. My S is okay.
Remember the S? We took we had like subtraction and then square, and then we had to divide at the end by n minus 1. we compute the S square and then we took the square root, etc. So that's where you get your S.
Yeah, no, I have my S. So I have my,
Okay.
I have my TC, I have my S.
And you have your
my
N too.
and
N
my
is just a number. Yeah, N is just the number of data values. How many
Mhm.
numbers you have, right? You have 10 numbers, so N is 10, and that's it. Then you can compute your E. Once you have your E, then yeah, then it's just this X bar minus E X bar plus
So
E.
I
Where
should be
X bar,
doing 2.821 times the standard deviation, and
Yeah.
then whatever I got from that, do the square root
Divide.
of n.
yeah, you divide by square root of 10. Yeah.
Okay.
And then here in the answer, this X bar, it's also from the first part. That's where you compute your X bar, the mean, the sample mean. This is
Mhm.
also from the first part 1 of the question, right?
So put that 2 on the bottom, what I got from the subtraction and the adding.
Yep,
Okay.
that would be the answer. Yes.
Okay.
Any other question, guys? Anyone else? So this actually covers sections 8.1 and 8.2, right? And as I said, the test you're gonna have probably some problems about sections 8.1 and 8.2. All right. Okay, we have like 25 minutes. I think probably we have time to do the last section, the 8.3. So this 8.3, it's also about confidence interval, but it's going to be confidence interval for the binomial distribution. All right, so let's discuss the last section 8.3 in
Maybe-
the.
I don't know. I was gonna say maybe if there's anybody that wants to go over like a section, would be the time to say something before he teaches something new that doesn't have to do with the test. But that's just me. I know.
Yeah, no, the thing is, I want to give you time to think about the review sheet. Solve the other problems in the review sheet.
Yeah.
Because I just posted the review sheet yesterday, right? Okay, I can, yeah, well, you know what? We can probably solve another problem from the review sheet. Do you have any suggestion, guys? Any problem from the review sheet? So I
didn't
guess
really get to look at it like that.
Yeah, I know. That's why. So I guess let me see.
Once I get the G, get the standard deviation, multiply answer and multiply the answer.
Okay.
And then n minus.
Well, you know what? We can probably do. Anyway, we're gonna have to solve all the problems in the review sheet. So I'm gonna start with like the first problem, etc. in the last 25 minutes. But the next time, so Monday, I will probably finish section 8.3, and then on Tuesday, I will finish. I will go over all the problems in the review sheet, I guess. Because we already discussed, the homework 5 and 6. So that would cover in some sense, chapter 6 and 7. But anyway, all right. So, okay. So let's.
Oh, I'm sorry, Professor, because I'm looking at my paper. So just like you said, my S was there, and then that last answer that you got with the 14.07 and the 23.13, you actually got that from your number 2, where you got your S. Yeah. So you just put that down at the bottom, and the only thing you got to really compute is the confidence level, which gives you the TC, and then you're divided by the square root of n minus 1.
Yeah,
that's a tongue twister.
No,
right? All right.
No, you don't. You divide by square root of n, not n minus 1.
Oh, so
yeah.
So, but n is always going to be minus 1 before I do the square root, right?
So no, to get the t subscript c, to get this t subscript c from the table 4, you need to take n minus 1. So like
Oh,
in our case,
before.
to get this t subscript c, we need n minus 1, right? Which is, we said it's 9. But in the formula of E, we divide by a square root of n, not n minus 1.
Oh, that's the other one, right?
Yeah.
Okay, I'm gonna go over this again a little bit.
All right, guys. So let's let's do the review sheet. I'm gonna start from the first problem, unless you have a specific request, guys. Otherwise, I'm gonna just start from the first with the first problem in the review sheet.
Oh, we're doing the, I thought we were gonna do 8.3.
Well,
Because we're
it's
not ready
because-
yet for the review yet. I didn't get to look at it yet like that. Everybody else is ready?
well,
No, I'm not ready either. I haven't had a chance to go over it either yet. You just said
Oh,
to us,
okay.
like,
okay, that's what I thought. All right, so okay, you know what? Let's finish section 8.3, and then next time, so we can discuss the review sheet.
Thank you.
So sorry about that, Yanine. All right, so
No, that's all right. I was just thinking about, reviewing for the test that we're
yeah,
getting.
because
But
I think
I'm fine.
probably some people, I mean, they need time to think about the problems in the review sheet. All right, so let's discuss section 8.3. So in this 8.3, it's the same thing. We're gonna try to, the goal would be to find a confidence interval for, so for 8.1 and 8.2, we try to find the confidence interval for the population mean mu, right? In 8.3, we're going to try to find the confidence interval for the probability of success P in a binomial distribution. So for the probability of success P in a binomial distribution. All right, so again, 8.1. So this is where we find a confidence interval for mu when sigma is known. 8.2. So that's, we in 8.2 we found the confidence interval again for mu, the population mean, when sigma is unknown. Now in 8.3, it's a confidence interval for the, as I said, confidence interval for the P, the probability of success P in a binomial distribution. Confidence interval for P, which is probability of success in a binomial distribution. All right, so just to remind you the binomial distribution. So when you don't see the, we have a problem, you want to find this confidence interval. So it's either for mu, the population mean, or it's going to be a confidence interval for the probability of success P. Okay. Now I'm going to remind you what do we have in a binomial distribution. Okay, so if you don't see like the word normal distribution, then that's probably a binomial distribution, right? Because the main two distributions that we studied here is the normal and the binomial. So if it's a normal, if it's not a normal distribution, then that would be probably a binomial distribution. So in binomial distribution, of course, we have two outcomes. There's a success, capital S, and there is a failure, and that's capital F. And there is a P, which is probability of success. And there's a Q, which is probability of failure, which is, we said, it's always 1 minus P. And there is N, which is the number of trials, right? And there is R, which is our variable, and that's the number of successes. Okay, that's our variable. All right. Anyway, guys, so for example, well, before the example, now, so the question now is, can we find a confidence interval for P when P is unknown? Confidence interval for P, the probability of success, when it's unknown. When it's unknown. All right. The answer, well, yes. And actually, we're gonna use. So the answer is yes, and we're gonna use. So to find this confidence interval, we're gonna use, the proportion of use the proportion of successes P hat in a given sample. Okay, so this proportion of successes P hat is equal to the number of successes. So P hat, it's called, again, this is the proportion of successes. This is just the number of proportion of successes. So when you have a sample, you can take the number of successes and divide the number of successes by the size of the sample. So for example, so let's say we have a random sample, of 188 books. Bought at a bookstore, and suppose 66 books were murder mysteries. Okay. So when you take a book, you take a random book. We have 188 book, right? Books. So if you take a random book, you select a random book, then of course here you don't see any. It's just a sample, right? You have a sample of 188 books, and you know that out of the 188, 66 books actually are murder mysteries, right? So we have this sample of 188 books. So there is no normal. We don't have a normal distribution. We don't have anything here. We have just a sample, right? Now, the thing is, so we are interested, let's say, in the number of the books which are murder mysteries, right? So when you select a random book, of course, either the book is a murder mystery, or it's not. a murder mystery, right? So there are like two possible outcomes when you select a random book. And again, here we are interested in murder mysteries, right? So when the book turns out to be a murder mystery, then that will be a success. That's what we're gonna call success. And if it's not, then that will be like a failure. Okay. Now, if I take all the books in this bookstore, okay, do we know what's the percentage of murder mysteries in this bookstore? Well, we don't have the percentage of murder mysteries in this bookstore, right? But we have this sample, just a sample of 188 books, right? And we know that out of 188, 66 are murder mysteries, right? So this is just a sample. This sample, of course, doesn't represent all the books in this bookstore, okay? So we don't know the percentage. So here, the probability of success P is unknown because we don't know the percentage of murder mysteries in all the books in this bookstore. So because we don't know the percentage, because this percentage would be your probability of success. So the percentage of murder mysteries in all the books at this bookstore. Murder mysteries of all, percentage of murder mysteries in all the books. Okay. I don't know. Let's say this bookstore has like 10,000 books, right? So we don't know what's the percentage of the murder mysteries out of the 10,000 books, right? However, we have this sample of 188 books. So in this sample of 188, we have a sample. So we have a sample of 188 books. Okay. And out of the 188, we know we have 66. 66 are murder mysteries, right? So the number of successes here is 66 out of 188. Okay, so the number of successes here, that's the number of murder mysteries. And that's actually equal to 66. So the proportion of successes here in this sample, this is a sample of 188 books. So out of 188, 66 are murder mysteries. So the p hat, the proportion of success in this sample, proportion of success. So it's 66 over the 188, right? So proportion of success, again, it's the number of successes divided by the size of the sample. Size of the sample. So we have 66 murder mysteries out of 188 books. Okay, so that's p hat. That's a proportion of success here. Again, this proportion of success, that's not your p. That's not the probability of success. You know, if you want to find the probability of success, you need to take all the books in the bookstore and count how many murder mysteries are there, right? So let's say in this bookstore there are like 10,000 books. So you need to count how many murder mysteries in the bookstore out of the 10,000 books. Here we just have like a sample. So this sample doesn't represent all the books. It's just a sample, right? So we don't know the probability of success P. We don't know the percentage of murder mysteries in all the books in the bookstore. So yeah, so this proportion of success, p hat, it's 66 divided by 188, which is actually equal to 0.35. So that's your p hat. All right. Now the idea is to use this proportion of success, okay, to get an estimation of the probability of success p. So now what we're gonna do, so the idea is use this p hat to get an estimation of p. So estimation of probability of success. All right. And so the estimation, of course, is going to be given by the confidence interval. So our confidence interval in this case, confidence interval. So instead of x bar minus e, x bar plus e. So instead of x bar, we're going to use this p hat. So the confidence interval is actually given by p hat minus e, p hat plus e. So it's going to be confidence interval, it's p hat minus e, p hat plus e. Okay, so the difference between the section, this section and section 8.1, 8.2. So instead of x bar, the sample mean, okay, we have this p hat, which is a proportion of success or proportion of successes in your sample. Okay. All right. Now, of course, the question is, how do we compute this e? So the good news is that this p hat actually has or can be approximated with a normal distribution. So for E, the formula for E would be the following. So E would be equal to the Z subscript C again, okay? Well, remember guys, you know, when sigma is known, the E would be like Z subscript C times sigma over square root of n, right? In section 8.1. So this actually, so this p hat, let me just say here, p hat can be approximated by normal distribution and you know, like what we did in section 7.6 when approximated by normal distribution by normal distribution. Now this normal distribution, it's a sigma. Remember, for binomial distribution, the sigma is square root of n times p times q, and the mu was n times p. So here, so instead of sigma, we're gonna have square root of p hat times 1 minus p hat, which is like a q hat, over square root of n. Okay. And again, I got this. So this is just, you know, you just compute the sigma and you know, sigma for the standard, the binomial distribution. Remember, we said the sigma is for a binomial distribution can be it's actually equal to square root of n times p times q. So this is exactly the same thing. The only difference here is that, so this p hat would be an approximation of p. So instead of using, you know, n times p times q, it's n times p hat times q hat, right? The q hat is just 1 minus the p hat. So yeah, so this would be the error E when you have a binomial distribution. So this is just, so this is the formula of E in this case.
And Professor, this is going to
Yes.
be on the final?
In the final, yes, not in the test two. So this is in the final, but not in the test two. In the
Okay.
final, yes. In the final, yes, but not test two. So yeah, it's exactly like the 8.1 where we have to find the Z subscript C. But it's just the formula for E is different. Okay. So yeah, so for example, let's do the example with the bookstore. Example again, we have this bookstore and we have this sample of 188 books. So bookstore with we have a sample, a random sample of 188 books. The bookstore, and out of 188, 66 were, we said, murder mysteries. So the question is, let's say you want to find a 90% confidence interval for P, the probability of success P, which is actually, this is the percentage of murder mysteries in all the books at this bookstore. All the books, right? And again, as I said, this bookstore doesn't have just 188 books. It has like, I don't know, 10,000 or whatever. All right. So this percentage of murder mysteries in the old books, the P, that's your probability of success, P. And yeah, so your confidence level would be this 90%. That would be your C. Okay, confidence level is C. So as a first step, guys, I want to find this confidence interval. So confidence interval, we said is supposed to be this P hat, this proportion of successes minus E, P hat plus E. So as a first step, you're supposed to compute the P hat, step one. So P hat. So we already computed the P hat, right? The proportion of successes. We have 66 successes out of 188. So this is 66 over 188. So the percentage of murder mysteries in the 180 in the sample, the 188 books, and we said it's 0.35. 0.35. And then as a second step, so step two, we are supposed to compute this error E, right? So E, but then we said it's Z subscript C. So it's square root of this P hat times 1 minus P hat, and then you divide by square root of N. All right, so the I mean the N, of course, the N, that's the size of the sample. We have 188 books. That's the size of the sample. I'm sorry, I'm over time, I guess, but let me just say, and probably I'm gonna finish this next time. So to find this Z subscript C is the same thing as we did in section 8.1. So we're gonna use this table, the bottom of the table 3, with confidence level C equal to 90% in this problem. And then P hat, we know P hat, it's 0.35. And then 1 minus P hat is just 1 minus 0.35, which is 0.65. Anyway, I'm gonna stop here, guys. Well, I want to finish this next time, I guess. Yeah, so thank you for listening. And so Monday, please prepare your questions. So I guess I'm gonna probably go over the review sheet on Monday. So please prepare your questions for Monday. Thank you, everyone, and enjoy your weekend. Thank you for listening. Bye-bye.
Thank you.
Bye. Have a good weekend.
You too. Thank you, guys.